This training video outlines the steps to create your first PLC circuit in Automation Studio. In the process of recreating this circuit, the user will learn how to create a PLC circuit with generic components from the library, how to do circuit addition, how to assess component properties and help, how to create a ladder logic, and how to run simulation and analyze the circuit. In this video, we will create a circuit where a pneumatic cylinder will be controlled by PLC. All components needed for this first circuit are contained in the main pneumatic library. Simply click on it to display components. In order to create the circuit, move the components from the library onto the schematic. To do so, select the desired component from the library, in this case a pneumatic pressure source, and drag and drop it onto the schematic while holding down the left mouse click. Similarly, drag and drop a double acting cylinder, a 5x2-way valve with a manual command and a solenoid, and 2 exhausts. To zoom in the schematic, go to the View tab of the ribbon bar and click on Zoom in function under the Zoom tools. Other zoom functions like Zoom Page, Previous Zoom, Zoom All components can also be found at this location. Alternatively, to zoom in and out, press and hold down the Control key, then scroll up to zoom in and scroll down to zoom out of the page. Software will zoom where you are pointing your cursor. To pan the document, click on the panning function of Zoom tools. When you click on the panning function, the cursor transforms into a hand, and then you can pan the document by holding the left mouse click and moving the cursor. Alternatively, you can press and hold down the space bar and move the cursor to pan the document. To disable this function, just right click on the document. Now connect all these components to create the pneumatic circuit. To connect components, move your cursor over a red connection port and click when the target sign appears. Release the button, draw your line with the cursor and click on a second connection port to establish connection between those two components. Both connection ports automatically become black when linked. In order to connect the exhaust with the directional valve, select an exhaust and drag and drop its connection port over the connection port of the 5x2-way valve. Similarly, connect the other exhaust to the valve. In order to connect the working ports of the 5x2-way valve with the cylinder, you need to change path during connection. To do so, when drawing a line while moving your cursor, click when you need to create a 90-degree turn and connect. Similarly, connect the other working port of the directional valve with the cylinder. Now that all the components are connected, you can start the simulation. Go to the Simulation tab of the ribbon bar and click on Normal Simulation icon under the Control Tools to start the simulation. While in simulation, when hovering over a component, if the cursor turns into a hand icon, you can click to interact with that component. The directional valve on this circuit has two commands, a lever and a solenoid. Since the control circuit is not yet created, activate the manual command by clicking on the lever to get the extension and retraction of the cylinder. Now stop simulation by clicking on Stop Simulation icon under the Control Tools. Let's learn how to add the PLC ladder logic. Before that, make sure that the layout leaves you enough space to add the ladder diagram on the same page. To do so, go to the View tab and click on Zoom Page function to see your entire page. Now click and hold the left mouse button and move the cursor to select all the components, then release the mouse button. After that, drag and drop the selected components to the top center of your page. Now add PLC input-output cards. For that, navigate through the Electrical Control JIC Standard Library and select PLC Cards category. Drag and drop a PLC input card and a PLC output card. Make sure to place the input card on the left and the output card on the right. Please note that the same logic circuit can be built using the IEC standard. Click on Zoom All Components to improve the visibility of the circuit. Now you need to connect the electrical components to the input card. From the Electrical Control JIC Standard Main Library, drag and drop a power supply 24 volts, a common 0 volts, and a normally open push button. When inserting an electrical control component on the schematic, the software asks for an alias for the component which is displayed on the schematic, and this alias is used to identify the component while linking it with other components. Give it an alias PB1 and apply. Now connect all these components to the input card in this way. Similarly, connect the electrical components to the output card. Drag and drop a power supply 24 volts, a common 0 volts, and a solenoid DC AC, and give it alias A plus. And connect these components to the output card. Note that the same applies to the IEC standards. Now that we have connected the electrical control components, we can focus on the ladder diagram which contains the logic in that circuit. From the ladder for AB PLC main library, drag and drop the rung on the schematic and place it between the two PLC cards. Your rung may be too big or too small or overlap on your cards. Simply click on the green square to resize it between the two cards. Now again from the ladder for AB PLC main library, drag and drop an examine if closed and an output energize to create the logic circuit. When inserting a ladder logic AB PLC component on the schematic, the software asks you to give it an alias. This will be the tag displayed on your schematic and will be used for linking components. Give it an alias out note and apply. Now connect these components to the rung. The examine if closed component has a question mark symbol above it. This means that it is not linked to any electrical component and hence link it to the input card. For that, you need to access the component properties window of the component. To open the component properties window of the examine if closed, right click on it and select component properties. You can also open the component properties window by double clicking over the component. Click on the variable assignment from the left side menu. Use the filter from the compatible simulation variables sections to sort the variables and only show the one matching your criteria. Here the components needs to be linked with the PLC input card, so write alias IN of the input card. Since the input signal is received at IN0, so double click on it to create the link. You can observe that the question mark symbol has been replaced by E1_1.IN0, confirming that the link is created. You can also see in the association span that now there is an association between the two components. Close the window. Similarly, link the output energize to the out node of the output card. All components in Automation Studio also have a help file describing their functionality. Right-click on the component and select Context Help. In this window, you can get information about the operation of the component and its features. This window also provides a description of each property of the component available in the Data tab of its Component Properties window, such as properties related to its modeling, characteristics, external data, operating conditions, and so on. You can also access the help file by clicking on the component and pressing the F1 key of the keyboard. Now link the electrical solenoid of the directional valve with the electrical solenoid of the output card, as the question mark symbol beside it suggests that it is not linked to any electrical component. Double click on it to open the component properties window. Click on the variable assignment from the left side menu. Click on the left solenoid icon of the directional valve. Here, left solenoid of the pneumatic directional valve has to be linked with solenoid of the electrical control circuit, which has alias A+. So write A+ in the filter. Once identified, double click on the alias to create the link and close the window. Now that all the components are connected and all the links are created, you can start the simulation to see your circuit come to life and the interaction between the different technologies. While in simulation, click on PB1 to energize IN node, which will close the open contact and which will activate the out node to energize A+ on the output card and on the directional valve, which makes the cylinder extend. Each time you release the PB1 button, the cylinder retracts because of the spring on the directional valve. Let's change the schematic so that one push on PB1 makes the cylinder extend completely. For that, stop the simulation first and then move the output energize out node 2 connections below by disconnecting it. To do so, press and hold down the shift key. Then click on it and drag it to the required place on the schematic. This will leave room to add internal bit on the first rung. Now from the ladder for ABPLC main library, drag and drop to examine if closed. And an output energize, which is the internal bit, and give it an alias B3 colon not and apply. Connect the added components to complete the circuit in this fashion. Now link the two examine if closed contacts to the internal bit relay B3 colon not. Once these links are made, you can launch the simulation. By clicking on PV1 this time, the cylinder extends fully but doesn't retract since there is no element to de-energize out node, which is now latched. Let's add a timer to make the cylinder retracts after 5 seconds. Stop the simulation. Navigate through the ladder for ABPLC library and select timers category. Drag and drop the timer on delay on the schematic. From the contacts category, drag and drop and examine if closed. Connect the on delay timer as well as examine if closed with the rung. Now link the newly inserted contact to the internal bit B3 colon not. Once the on delay timer is in place and connected, add the timer done bit DN contact in the circuit to de-energize B3 colon not once the preset time on the timer is reached. Drag and drop and examine if open contact from the context category of ladder for ABPLC library directly on the first line between E1_1.in0 and B3 colon not. When dragging a component from the library, if you drop it directly on the line, it will automatically insert that component in the circuit. This will not work, however, if you drop the component on your working space before. For example, if this contact is dragged and dropped on the workspace first, and then if you drag and drop it directly onto the line, you can observe that the ports are still red. This indicates that the component is not inserted correctly. Delete it by clicking on it and pressing the delete key of your keyboard. Now link the examine if open to the timer done bit of your timer DN. Double click on it to open the component properties window. Search for DN in the filter section. Double click on it to establish the link and close the window. By default, the timer has a preset time of 10 seconds. Change its value to 5 seconds. To do so, double click on the timer on delay to open the component properties window. Click on the data tab from the left side menu. When the star is filled orange, it means that only the favorite fields are displayed. Click on the star to display all the fields and find the pre-field. Change the value of this field to 5 seconds and exit the window. Now that your circuit is completed, launch the simulation to see your entire circuit come to life. Click on PB1. The cylinder will extend and the timer on delay will be activated. Once it reaches the 5 seconds preset time, the DN contact will de-energize B3 colon not and the cylinder will retract since out not will no longer be activated. Similarly, you can create different PLC circuits in Automation Studio.